name. Today I am going to start lecture on identification of amines. In one of the previous lecture, I started off with the litmus solution test. I discussed if we give you an unknown compound in a lab and ask you to identify the nature and the chemistry of the given compound, you people need to start with the litmus solution test. Once you perform litmus solution, the test confirms whether the given compound is a sort of an acidic in nature, or the given compound is sort of basic in nature, or it may be a sort of a third category, mean the given compound is a sort of a neutral in nature. So once you have a unknown organic compound and you start off with litmus solution, test, I've told you three possibilities. The litmus solution may confirm the given compound is acidic, or the given compound is basic in nature, or it is neutral. We have gone through this schematic description in one of the previous lecture, that is on lab activity. So the acidic compounds would be either phenols or they would be carboxylic acid. Two categories of the compounds do fall in acidic class. Secondly, if you perform litmus solution test on an unknown given compound and the test turns out to be about the presence of the basic compound, then means the given compound may be an amine. However, if the litmus solution test confirms the unknown compound is neutral, then it could be a carbonyl compound. It could be a carbonyl compound, or it could be a carbohydrate. So this is the starting point about the identification of unknown compounds in the laboratory using different confirmatory tests. So once you started off and the litmus solution confirmed the given compound as an amine, then we told you that the amines could be confirmed by diazotization test, or it could be confirmed by Carbylamine test, or the test number 3 could be Hinsberg test. So once you came to know that the given compound is basic in nature, so you may apply the diazotization test for the confirmation, or you may go for the usage of the Carbylamine test, or you may move for the Hinsberg test. In one of my last video lecture, I've given you a very comprehensive lecture about the chemistry of the diazotization test. Once you perform diazotization test, diazonium salts are produced, and those diazonium salts undergo coupling with some sort of an aromatic compound like phenols, and the formation of some colorants inside the test tube confirms the starting compound was a sort of a primary amines which would have undergone diazotization, and the diazonium salts would have undergone a coupling, giving you a colored product inside the tube. So it confirms the presence of a primary amines diazotization cells. For the performing of this test, one should be careful to keep the temperature less than 5 degree. We are supposed to use ice jackets. Sometimes if you are uh, to do the identification of an amines and you came to know that you don't have an access to the ice is not available in the laboratory, then maybe the diazotization test will not be possible for you. You may go for the carbylamine test in order to confirm the presence of amines. So today I'm going to explain the chemistry of the carbylamine test, what happens inside the flask when you mix your given amine with the reagents of this specific test, what happens inside the test tube, and the evolution of foul smell, obnoxious smell that confirms the amine is present in the starting compound. So this is how one can confirm the presence of amine by applying carbylamine test. Once, if you don't have the access to the ice or the other reagents involved in the diazotization site. So let me explain the carbylamine test for the identification of amines. It's a carbylamine test. It is also called as isocyanide test. The second name of this test is also cyanide test. Why it is so, I will explain in my further talk. Secondly, this test also confirms the presence of primary amines only, as was the case with diazotization test. The diazotization test is also applicable only to the presence of primary amines. If primary amines are present, they will undergo diazotization to produce diazonium salts. Similarly, over here, this carbylamine test is applicable only to the amines which are primary. If you are given a secondary or tertiary amine and you perform carbylamine test on that given compound, this test will turn out to be negative on primary and secondary amines. And those primary and secondary amines, they can be alkyl amines, or they can be aryl amines. Alkyl amines means the amines with the linear chain. Alkyls, something like that they could be. Aryl amines, one very prime example is the aniline, means the presence of aromatic ring, aryl amines. So both alkyl amines and aryl amines could be confirmed by using carbylamine test. Okay, what the condition is, they are supposed to be primary amines. If we have a sort of, let's say, tertiary, or we have a sort of tertiary or secondary or tertiary amines, obviously they will not be detected by the carbylamine. So they're supposed to be primary in nature. Whether they're alkyl or aryl, that will not be a problem, you know. So this is how they're supposed to be. So what happens actually in this test? The isocyanides are formed. The formation of isocyanides produces odor, you know. Formation of isocyanide produces bad smells, obnoxious smells, foul smells, you know. Foul smell. So evolution of such smells from the test tube will give you clue that your compound is a primary amine, you know. So this is how this test helps you to confirm the presence of primary amines. How the test is performed, you know. Once we ask you to identify the given unknown amine, what happens then? What you could do, just put in solution of potassium hydroxide, and then you may put in around 1 to 2 mLs of your amine, the given unknown amine, given compound, you know. And thirdly, you may put in chloroforms into the test tube, and then we need to heat the sample. What happens then? This sort of isocyanide is generated inside the test tube after the heating for a few minutes, you know. Isocyanide, the bad smell from the test tube will confirm the isocyanide has been formed inside the tube. How the isocyanide has been formed? The isocyanide will be produced from the corresponding primary amine. So if the primary amine was there in the beginning, the compound which has been introduced in the beginning in the test tube, if that was a primary amines, then accordingly it would have reacted with the reagents and would have get converted into the isocyanide. So one can say the given compound was a primary amine, you know. So this is how the test is carried out in the lab in order to confirm the presence of amine. This is called isocyanide, you know. We have an idea such compounds are called cyanides. Cyanide, you know, the compound is called cyanide. However, the shuffling of the position of the carbon and nitrogen, then this compound is called isocyanide. So in this reaction, inside the tube an isocyanide is generated, and this generation confirms the presence of an amine. This is the basic about the reaction which actually occurs inside the test tube. So what is the mechanism behind this reaction? How an amine is converted into an isocyanide, what is the role of potassium hydroxide in this reaction, and what is the role of chloroform, why we are using chloroform in this specific reaction. This is what I'm going to explain to you in a mechanistic way, so that you can have an idea about the usage of these two components against this added amine to produce the product in the form of an isocyanide. So what happens actually, as we have just discussed, that we put in chloroform in the test tube. It is something like that. And we have used potassium hydroxide, that is a sort of a base, we have an idea. What happens is this basic entity, hydroxyl group in the form of a base, has the ability to pull this proton out from this carbon. In general, the chloroform is not supposed to be that acidic. However, in this case, the presence of the strong base and also the electronegative effect of these three chlorines, as they are more electronegative than the carbon, they pull this electron towards chloro, leaving positive charge on the carbon. In order to neutralize those charges, the bond between carbon and hydrogen pulls towards carbon, and then this proton becomes a bit looser, a bit loose entity with the carbon. Resultantly, it could be removed a bit easily by the hydroxyl group from the base, So resultantly, what happens then, we will have the carbon is supposed to carry the negative charge because it has the electron of the hydrogen, so it will have a negative charge. As we have an idea, the chlorides, the chloro groups, the chlorines attached to the carbon, they are more electrophiles. It will move away, taking the both electron from the carbon, giving us this sort of a compound, and this chloride along with K, it will be removed in the form of KCl, So this negative charge could be represented in the form of a lone pair, in the form of 2 electrons. This sort of a compound is called carbene. Carbon having lone pair of electrons is called carbenes. It carries at the moment 2 halogens, 2 chlorides, 2 chlorines, one can write it dichlorocarbene. It has been formed, This carbene, dichlorocarbene, is electron deficient. It needs electron. Why? Because its octet is not filled. At the moment, how many electrons are available in its octet? 2 in this bond, 2 from this bond, and 2 in the form of a lone pair. So 6 electrons are available in the octet of the carbon. It needs 2 more electrons, So that is why it is an electron deficient. So somebody who's an electron deficient is supposed to be an electrophile, At this point of time, what happens? We can write over here as KCl in the form of minus. What happens if we bring in our amine amine, the one which we are going to test in this very confirmatory test, the amine which we introduce into the test tube, This amine, we have an idea the nitrogen has a lone pair, so it can donate lone pair to carbon, so it will be acting as an electrophile, this will be acting as a nucleophile. So the lone pair will move from nitrogen to the carbon, resulting in a reaction, and the product is supposed to be something like that. We will have carbon, we will have a nitrogen having 2 protons, as it is a primary amine, we will have an R here. Secondly, the carbon carries 2 protons as well, so it will look like this one. What happens then, as the nitrogen has given the lone pair to the carbon, resultantly it got 4 bonds, so the nitrogen is supposed to be of a positive charge, over here. It is supposed to carry a positive charge. So what happens then, at this point of time, another molecule of KOH, that is base, can come in to remove this proton from the amine, in order to settle the positive charge on the nitrogen. This proton is taken away by the hydroxyl of this base. As a result, this bond is shifted between carbon and nitrogen. Because carbon needs electron, carbon is an electron deficient, So what happens then, you will have CH2, we will have a nitrogen over here, something like that. We have a R here, one of the proton has been removed, I'm sorry to say, these are not the protons, these are the protons, but here we have 2 chlorines attached to the carbon. So as soon as the bond is shifted from here to here between carbon and nitrogen, this chloro will be moved out as a leaving group in the form of a chloride, and it will react with K to move in the form of KCl, So what happens then, there will remain only one chlorine connected to the carbon. Then again, another molecule of the base can take this proton out, because it's a strong base, it can take proton out. Resultantly, this bond between nitrogen and hydrogen will move over here, and this chloro will move out as chloride again, Cl negative. It will make a bond with the K. I would write it over as KOH. It will move out as KCl again. So we will have R, N, and then triple bond C. So this will be the bond between these 2 bodies, where 2 chlorines attached to the carbon, they have been moved out, they have been removed, They have been removed. due to the involvement of these two basic molecules which have come from the potassium hydroxide, and that's the base, and it has the ability to obstruct protons. Those protons then they are removed from the nitrogen. Resultantly, the bond between nitrogen and hydrogen is moved to generate a new bond between carbon and nitrogen. And this happens two times because two chlorine were attached with the carbon. So this is how the product will look like. You may write it this way. You can write R and triple bond C. So this will be called as isocyanide. This will be called as an isocyanide. So as soon as this isocyanide is generated inside the tube where we have performed the carbonyl-amine test, we will feel a bad smell, a foul smell, an obnoxious smell, that will not be pleasing. So that smell actually comes from the formation of this isocyanide. So once you smell, that smell is it's a foul smell, So one can imagine the isocyanide has been generated. Why it would have been generated? Because it would have been generated due to the presence of a primary amine. This primary amine finally gets converted into isocyanide. If you have a tertiary or secondary amine in place of primary amine, then those secondary and tertiary amine would not be able to give you the corresponding isocyanide. So resultantly there would not be any obnoxious smell coming out of the test tube. So one can imagine that okay, the litmus solution and confirms the given compound is a base, mean it's an amine. However, when we have performed a carbylamine, there is no bad smell. We haven't smell an obnoxious smell, So one can say that okay, that is amine, but that given amine would be secondary or tertiary, but it is not primary. So this is how one can confirm the presence of primary amine using carbylamine test or isocyanide test. I've told you in the beginning that the presence of primary amines could also be confirmed using diazotization test. That test is also very simple, You need to use sodium nitrite along with HCl, and the formation of yellowish brown color suggests the formation of diazonium salts. Then they're further coupled with some aromatic compounds. Their coupling results in the formation of colored compounds inside the test tube. The color production suggests the starting compound was a primary amine. So there are two tests. One is diazotization test, the other is carbylamine test. Both tests helps you to identify the unknown given primary amine. For diazotization test, you need to keep your temperature from 0 to 5 degree. You need to use ice jackets. If you are unlucky and the ice is not available in the lab, you can go for the carbylamine test. It will serve you the same way to help you to identify the presence of primary amines. Why we need to identify primary amines? As a first response, being student, you should have an idea how to identify any unknown given compound, acidic, basic. Let's say if the litmus solution confirm basic, then yeah, you need to do either diazotization or carbylamine. Okay, the other way, if you are a student of a color chemistry, if you are a student of a color chemistry and you are interested to produce an azo dye, an azo colorant, azo dye azo colorant, you know, then you can use primary amine for that very purpose. What you need to do, you know, you can start with the primary amine, you need to perform the diazotization, then you bring in the relevant coupler as per your desire, as per your choice, as per your requirement. The coupling of the diazonium salt with the aromatic compounds results in the formation of azo compounds, azo colorants. If you convert those organic colorants into their corresponding salts, they will become the azo dyes. For that very purpose, if you want to generate an azo dye, you need to have an idea whether the starting compound is an amine. If it is an amine, what sort of the amine is it? Because for the preparation of an azo dye, the given compound should be a primary amine. So if you want to check whether the starting compound is a primary amine, then you can apply the Carbylamine test. So this test is important in this way, in a way that if you want to identify any given unknown basic compound, if your lab instructor, your teacher has asked you to identify. Secondly, if your teacher has asked you to prepare an azo dye from a given unknown compound, for the very first, you need to have an idea whether that given compound is a primary amine. If that's a primary amine, then you can move on to generate to produce your azo dye, azo colorant. If your starting compound is not a primary amine, then straight away you can't use that for the preparation of azo colorants, azo dyes. So this is how this test is very important for the preparation of dyes, azo dyes, as far as its practical application is concerned. Secondly, the students who are in the lab and they are interested to learn to identify compounds using different conformity tests. So this Carbylamine test is very much important for them as well, to identify given unknown compounds. I hope you got the message. You have got an idea about the identification of the amines, especially the primary amines. Now in next lectures I will try to explain the chemistry of the Hinsberg test, and I will try to give you idea how the primary and secondary or tertiary amines could be separated from each other. If you are to distinguish between primary, secondary, tertiary amines, how you could do that. That will be topic of my next talk. So from today's talk, that was related to Carbylamine test, the chemistry, the mechanism I've explained to you. If you do have any question in your mind, please don't hesitate. You can put the question in comment area, or you can send me an email. I will be happy to respond, inshallah, at the earliest convenience. Again, thank you very much for your precious time and attention. Thank you very much, dear students.